Okay, so we're going to continue with trig. Now, again, the reason, so you know the reason we're doing this is not for no reason at all. The next few chapters, we're going to look at things that are at angles. So, for example, an object launched at an angle, forces applied at angles, work done, going upstairs maybe at an angle. Inclined plane, so motion down an inclined plane has an angle. Without these angles, without trig, we can't, God bless you, we can't really describe what's fully happening here. So, again, last class we left off by looking at labeling the triangles opposite, adjacent, hypotenuse. That's where we left off. Today we're going to pick up from there. So let's start with the acronym that we wrote down at the beginning last time. It's SOHCAHTOA. Okay? Now, remember, the acronym is made to help you. This tells us that the sine of some angle is the opposite over the hypotenuse. This tells us that the cosine is the adjacent over the hypotenuse. And this part tells us that the tangent of an angle is the opposite over the adjacent. So the acronym is meant to help you memorize what each of the trig functions are. For the sake of physics, once we get through what sine, cosine, and tangent are today, you're going to see that all you're ever going to use are really sine and cosine for this class. You're not going to use tangent as much. Tangent would really come into play if we were trying to find the angle at which an object landed at the ground. So imagine an object is fired at some sort of an angle, say 30 degrees, and it's launched and it comes down off a cliff and keeps going out further, and you want to find the angle that it lands at. That's where tangent is going to come into play. All right? For the most part, though, we're going to be using sine and cosine. Right? Sine and cosine. Now, if I asked you, if I gave you a triangle, okay, so some given triangle, let's say for the sake of this example that this angle is 35 degrees. This is a right angle. So we have a right triangle. Now, remember from right triangles, what theorem did you use to find the different side lengths? If you knew two of them, you could find the third, right? Pythagorean theorem. All right. Now the question becomes this, though. What if I'm only given this as, let's say, 5 centimeters? Okay, you're only given one angle and it says 5 centimeters. One side length, sorry. And it says 5 centimeters. And you're asked to find the other two side lengths. Pythagorean theorem is not enough to do that, clearly. Because Pythagorean theorem, we would need to know that this is 5. We would need to know what this quantity is to find the hypotenuse. Or know the hypotenuse to find the missing leg. So what we're going to do today is discuss how this will work. Jeff?
Usually, since you know two angles on one side, can't you probably figure out the opposite or something that's like, because like it's like smaller or larger than 5%?
Close. You're on the right track there, Jeff. You're on the right track. You could definitely find the third angle right away, because you know all the angles add up to 180. Then if you know the angle over here, the angle here, you could find this side. And we're going to do that today using SOHCAHTOA. Okay? Sash?
You could do a cos where it says.
Where you getting? It's not cos. Be careful.
Oh, I'm sorry. For that side, I was going to do the hypotenuse. Okay.
Okay.
So you could do
Let's label first, Sash, just so everybody's on the same page. You would label this hypotenuse, right?
yeah,
What would the given be down here?
adjacent. And
Adjacent?
The green thing is opposite.
So we all clear on that? Let's make sure we're all clear on that first.
So
The angle is given over here, so this must be the adjacent right next to it. This longer leg across from the 90-degree angle is always the hypotenuse, and by default, the last one is opposite.
So is opposite always, sorry,
All right, time.
opposite?
Continue. Give me a second.
8 tan x over 5.
Okay, so before I need a statement though. Don't give me the answer. I ask for a statement. So give me some sort of a cosine or sine statement at the beginning.
Okay, tangent equals opposite over hypotenuse.
Okay, so tangent of 35. So he's looking at this angle right here, and he's going to use this tangent function. TAN is the abbreviation for tan. We're assuming everybody's never seen this before, because most people have never seen this before. Okay? So tan is the abbreviation for tangent. You'll see it on your calculator. Now, tangent of 35. The tangent function is defined as opposite over adjacent. Opposite over adjacent. So here, let's call the opposite in this problem x, and let's call the hypotenuse in this problem y. Continue. What would I write the proportion as?
So then it would be x over 5 centimeters.
Good. Again, let's go through this now.
You could, if you want to find x, you would multiply times would be 5 centimeters.
Very good. We're going to rearrange it. So let's slow down now again. 35 degrees is given here. This is the side opposite that. This is the side adjacent to that. If I wanted to find the opposite and I know the adjacent, think about opposite and adjacent and look at your trig functions. The only one that has opposite and adjacent is the tangent. This one has adjacent hypotenuse. This one, sine, has opposite hypotenuse. So if you wanted to find x over here, which is the opposite, and you have the adjacent, that means you have opposite and adjacent. By default, you automatically go to tan. That's why Stash said, let's start with tan 35 equals the opposite, which is x, over the adjacent, which is 5 centimeters. Jack?
Yeah, I don't
Why
know.
do you put 35 next to 10?
And that's what I'm going to discuss now. You guys have never seen this before, so I'm trying to go real slow. So I got to go slower. I know you know how to do this. That's fine. Read a book for a little bit if you want. It's fine. It's not wrong. I'm being honest, though. I like your cooperation and participation, but I got to go slower because people have never seen this. All right. Now, 35. 35 is called the argument. Okay, the argument. And what you're doing here, and you guys have studied functions before, like f of x equals some value. Right? You've seen this?
Yeah.
This is like a function. This is the tangent function. So this is like your independent variable x here. So you're doing the tangent of 35, and you're saying that equals x over 5. Okay? So if you want to find x, remember how we talked about in physics, v equals d over t? I said you could just take this here, and you can move it up by multiplying both sides.
Yeah.
Okay? If you move this 5 up here, what you're going to result in, okay, is simply 5 tan 35 equals x. And there's nothing here. There's really a times here. You're not going to see things there. If you see the number and then a trig function like tan or sine or cos, it means multiply. Now, in your calculator, and that's what I'm going to teach you how to do this just using your calculator this year. You can use trig tables. That's an old school method that I used when I was younger, when calculators weren't very apparent or very, what is the word? Not even advanced. Accessible, thank you. Accessible. So, if you multiply the number 5 by the tangent of 35, that will give you the length of this side right here. Again, it's going to give you the length of this side. Now, the key is the following. Take out your calculators, everybody, please, right away. Okay, before we begin this, you have to have the right mode. If your mode is incorrect, your numbers aren't going to make sense and you're going to get frustrated. Okay? Yeah, and you're going to see radians and you're going to see degrees. So, whatever calculator you're using, if you're not using the 84, figure it out on your own right now. If you're using an 84 and 83, it's the same thing. Press mode.
Wait, where's my mode?
You should get like the top left somewhere.
Next is second.
Okay, look at mode. Then, once you press the button mode, look down and see if radian or degree are highlighted. You want degree to be highlighted.
Where's the, okay.
Go down, hover over degree and hit enter.
Enter. Oh, no, I didn't.
Go down, press right to hover over degree, and then press enter and it'll be highlighted. The reason we're choosing degree is because our angle is in degrees. Had it been in radians, which is something I don't think you've learned yet, correct?
Correct.
You would use radian mode, but that's later in the year, and algebra 2 you're going to learn radians. We're always going to work in degrees in physics, so don't worry about it. Even degree mode. Okay? Okay. Everybody press 5. Now go to the home screen. Press second quit. Second quit. Go back to the home screen. Type 5. Then press the button tan on the calculator. See tan somewhere. Look for it in the middle. Then press 35.
Oh, yeah, it's blue. Sorry.
Press 35.
Oh, it's not.
Close your parentheses and hit enter, please. You don't even need to put the time symbol. Again, you don't need the times. You put it in the front. Okay? If I don't need parentheses, it's not either.
Close the parentheses and click enter.
You don't really have to close them, but close them to be safe. Because there's some
I got
time
it.
here. You gotta close them.
3.5. I was raising my hand.
Jack, what do you got?
3.501. Shit.
Guys, language.
That's not much.
3.501.
Yes.
Raise your hand if you got 3.501, please. All right, let's make this easier. Raise your hand if you didn't get 3.501. Okay.
Well, I don't have I'm 10.
All right, so 3.501. Now, watch what happens, people. Go up. Label the 3.501 back in the diagram, please. And let's approximate the 3.5.
So that's the length?
That is the length of that side, correct. That is the length of that side. Yeah, that's something we're good.
What is exclamation mark and divided by?
Exclamation mark?
No, what's it called? I don't know what you mentioned already. What is it divided by? It's like n to the power of something.
Exclamation mark just means every number below that integer value multiplied.
It means to emphasize something in America. What's it divided by? Also here in America.
What's divided by cos?
What is it divided by in cos function?
Are you looking at the series or the sequence of the numbers? I have to look it up. I don't know what it is. Ask me after, Josh. I gotta keep going. We cancel it after that.
Oh,
Okay?
yeah, we learned that one second grade.
So, five. No, what he's talking about is something with calculus, actually. It's far advanced, but beyond this. This is 5 here. This is 3.5. Use Pythagorean theorem and find out what the hypotenuse is, please. You all know how to do that. Use Pythagorean theorem to find out what the hypotenuse is, please. So 3.5 squared plus 5 squared equals c squared. Square root the sum of those two, please.
37.
Square root it.
Oh,
Square root it. Masha? 6.1? Approximately, thank you. All right. Now, that was using Pythagorean theorem. Let's prove that what we're doing is actually true. Here's what I want to do now. Using this side that was given here as 5, and using the hypotenuse, which trig function would I select? Again, using the 5 that was given, and this hypotenuse, which Tyson trig function would I select? Why? Good. Adjacent is here. Hypotenuse is here. So this would be cosine. Very good. Now, here's what I'd like you to do. Go ahead and write cosine of 35 equals adjacent, which is 5, over hypotenuse. Let's leave it as y for now. And let's leave it as y for now. Now, we said using Pythagorean theorem that this was 6.1. Let's prove that solving for y in this equation, that we get the same answer. Again, we're going to use the cosine function, because cosine is adjacent over the hypotenuse, to solve for this y variable. It'll come out to be the same thing as you did using Pythagorean theorem. How will I solve for y in this equation? How can I solve for y?
Switch those two, so
Very good. Go ahead, Molly.
divided by cosine 35 degrees.
Good. Flip-flop. Remember, we can do this. We did this with the v equals d over t. Go in your calculator, type in 5 divided by cos 35. And it might be off because of rounding. That's fine.
6.1.
It is exactly 6.1. Very good. 103.
Well, it's, yeah.
Good. Again, notice, we did this with Pythagorean theorem up here. We got 6.1. It's the same exact answer as if we had done this.
Yeah, I got the exact same.
So, before we go on to apply this to physics, the summary, and this is like the shortest version of trig you'll ever see. You'll spend like 4 or 5 days on trig. I'm spending a day and a half, not even. The summary of this is that we can find a given side length if we're given just the 90-degree angle, one of the angles, and only one side. Again, we were given the 90 angle, we were given the 35, and we were given this side length. And from that, we were able to determine the other two side lengths without even using the Pythagorean theorem. Is that clear? That's what the power of this is in a sense. And that's what we're going to use in a minute. So let's take a look at a problem in physics now. Let's say that you are, and watch what I'm going to do on the wall here. Let's say I was trying to, for some crazy reason, hold this bio book up on the wall. I might push straight against the wall at 90 degrees, but I might instead push at an angle upward. Makes it easier, right?
Yeah.
It's a lot easier. But now, see my arm? If I make a right triangle here, I'm pushing at an angle, and my arm makes the hypotenuse. This is the adjacent down here. This is the opposite. My arm is the hypotenuse. So let's draw a diagram of this to show you where it's going to come into play. So here's the wall. Here's the textbook against the wall. This was my hand holding the textbook, and this was my arm pushing up on the textbook with some sort of a force, let's say a force of 20 newtons. Okay? Newton is a unit of force. You've probably heard it before, maybe in physical science. Okay? It's like pounds. So if you push with a certain amount of pounds is the English unit, newtons are the standard unit. So if I'm pushing with a force against the book to hold it against the wall, I know that what's really happening is that part of me is pushing against the wall and part of me is pushing up. Again, take a look over here. If I'm pushing directly against the wall, I'm acting only against the wall. But the minute I start doing this, I'm acting against the wall, but I'm also pushing upward. So I have a horizontal component and a vertical component of my force. So this year, what we're going to learn is we're going to learn about breaking this into components. We're going to call this the horizontal component, Fx. And let's write this with a subscript, please. F little x. And we're going to call this, throughout the year, the vertical component, Fy. And notice, what shape does it make that we're looking at now? It makes a triangle, where Fx is the adjacent now, assuming this was our angle, let's say the angle is 30. Fx is the adjacent, Fy is the opposite, and the force that was given, which was 20, the force that was given as 20, very good, is the hypotenuse. Now, what I want to do, and this is the only thing I want to do, is show today what Fx and what Fy are in terms of cosine and sine. And then from this point on, we can just use the proof that we're going through. So, here's what I'd like to do. I'd like you to write an equation using sine, cosine, or tangent that relates Fx, the angle, and then the general force given as 20 newtons. So using Fx, right here, the force of 20 newtons, and this angle of 30 degrees, write an equation, either cosine, sine, or tan, decide which one it is that relates them, and then solve for Fx. Again, write an equation using cosine, sine, or tan with Fx, the angle, and then the given force, and then try and solve for Fx, and see what you end up getting for Fx. Not numerically, but just solve for it generally. You'll learn more about that sequence of series. Are you using the calculator now? You can just Google cosine function as a sequence or as a series. It'll come up. All right, quickly. With regards to this 30-degree angle, what would you call this side? Adjacent, opposite, or hypotenuse? Adjacent. What would you call this one? So which function are we looking at? Cosine. So CAH, C-A-H. Cosine is adjacent over hypotenuse. We have adjacent, we have hypotenuse. So we have, ready? We'll say in this case, the cosine of 30 degrees, because that's the angle, is equal to the adjacent over the hypotenuse. Everybody see that so far? Again, the cosine of the angle we have equals the adjacent fx over the hypotenuse 20. Now, if I want to get fx by itself, everybody, what do I do with this 20? Yeah, multipliers, bring it on up. So we'd have 20 times the cosine of 30 is equal to fx. So far, so good? Again, 20 times the cosine of 30 equals fx. This is the rule that you're going to generalize now. Whenever you're looking for the x component, you just take the hypotenuse and multiply it by the cosine of the angle. So what I want you to write down right now is the correlation that cosine, okay, is used to find the x component. Okay, again, doesn't matter what the triangle is going to look like. If you have this angle, and this angle is with respect to the horizontal here, so you're not, for example, we're not talking about this angle here. Again, we're not talking about that angle that makes a 90-degree angle there. That's not the angle we're talking about. We're talking about the horizontal line and then this hypotenuse. If you're given this angle right here, okay, if you're given that angle and you want to find fx, or the x component, you're going to use the cosine function. And I know it sounds weird, and I know it's going to sound weird. I'm telling you that now. But you're going to have to memorize that it's going to be cosine. You're going to do a lot more in math class about this. But if we don't go over this, we're going to be pretty much just, not having anything to do for the rest of the year. It's going to be a waste. We need to go over this. And I can't spend 2 weeks going over it like you might have.
Do you want me to get the answer for that?
Yeah, what do you got for this?
I got 17.3.
Good, because it's going to be 8.66 repeating times 20. Very good. So you're going to get approximately 17 and change. Now, what I want you to do next is do the same thing for Fy. Use Fy, use the 20 Newton force, and use the angle to come up with an equation as a representation. Same exact thing, but instead of Fx, I want you to write it in terms of Fy now. So you're doing Fy, the 20 Newton force, and the 30-degree angle. Relate the three of those using an equation. And think about whether it's tan, sine, or cosine. Scared. Right? Go for it.
Sine,
Of
30,
equals.
FY.
Good.
20N.
Hold on. Again, take a look. This is the opposite side from 30 degrees. Everybody see that?
Yeah.
Opposite, we're using that. That's Fy. 20 is the hypotenuse. Opposite hypotenuse is the first part of SOHCAHTOA. Remember, opposite hypotenuse is right here. That tells me to use sine. In the previous example, we had the adjacent and hypotenuse, which is why we had used the cosine. Okay? Previous example, we had fx, which was adjacent, and hypotenuse. We used cosine. In this example, we have the opposite, and we have the hypotenuse, so we're using sine. Solving this for Fy, what do we get for solving? Not numerically, just tell me what I would do. Jack?
You would bring the 20 over, so you times it by 20, so you have 20n times sine 30 degrees.
Good. So the correlation here is that when you want to find the y component, you're going to be using the sine function. These are the most important things. The cosine refers to the x, the sine refers to the y. That's pretty much what I wanted to get out of today's lesson and trick. Because this year, what we're going to do is we're going to say like, all right, I need to figure out if I'm, let's say I have a sine being held up, and I've discussed this last class, and say this angle is 30 degrees, and I want to know, I have, you okay?
What?
You okay?
Yeah, I'm good. Just check.
I have, imagine, we're going to draw these diagrams later this year. I have gravity acting down. I want to know how much of this tension in this cord is acting up. Well, that's Fy. If I want to know how much of the tension in the cord is pulling left and right, that's my Fx. So what we're going to be doing here, God bless you, is we're going to take things that are at angles and break them into their perpendicular components. So if we want Fy, we're going to do whatever this vector here is, whatever this magnitude is, times the sine of 30. If I want Fx, I'm going to use the cosine of 30. Okay? So again, to generalize, let me give you a generalization now. If you want Fx, you take the normal, whatever the force is, times the cosine. Have you heard of the term theta before in geometry? It looks like this. Have you seen that? Okay, theta is a general variable used to mean sine angle. So theta can be 30 degrees, 20 degrees, 45 degrees, whatever it is. Okay? And I'm going to say where theta is the angle between the force F and the horizontals. And I'll explain with the diagram what that means, okay? And Fy, I'll put that above here, so I'm going to run it a little below. Fy is going to be F times the sine of theta. Remember, theta is a variable. In geometry last year, you guys for angles would use A, B, and C? For capital A, capital B, capital C?
Yeah.
Okay. When you get to algebra 2 and pre-calc, and maybe next year I'll encourage your teacher in geometry to use theta and stuff because you're going to see it more. This just means some angle. Okay? It means some angle. So capital A, capital B, whatever. So for example, what I'm saying is this. If you want to draw a diagram, if this is some force, okay, this is theta. That's what I mean by theta is the angle between the force and the horizontal. Again, this is the force here, and this is the horizontal. That's where theta is always going to be. If theta is given you somewhere else, you need to find theta in that location for now. There are other ways to do it, but I'm saying that for now. So imagine you were given, God bless you, imagine you were given that this is a right angle, and you were told that this degree is 50. What would theta be? You were told that that angle is 50. What's left over for theta? How much, Jeff? 40. Because 50 and 40 makes up 90, and then 90 and 90 makes up the 180, which is a triangle. Again, remember the triangle, the sum of the interior angles is always 180. So in this problem, you would take theta plus 90 plus 50 is 180, so theta would just be 40. So if you're given this angle, please find theta and use that in your example. Okay? Now, remember, what is this telling me? If I want to know what fx is, that's right here. If I want to know what fy is, that's right here. So if you ever want to know what the vertical component is, you multiply the original times the sine of theta. If you want to know what the horizontal component is, you take the original times the cosine of theta. Okay? Again, all of this is right now, just for the sake of physics, because I know you haven't learned this before, is just remember these rules. Fx has to do with the cosine, Fy has to do with the sine. If I give you an example where an object is launched, and let's say it's launched with a velocity of 30 meters per second, but now that velocity is launched at an angle, and we'll say the angle is 20 degrees. If you want to find Vx and you want to find Vy, the horizontal component and the vertical component, you approach it the same way as the forces. All you do is you say whatever this was, 30 times the cosine of 20 degrees. Here you'll say 30 times the sine of 20 degrees. It doesn't change. If I use forces, if I use velocity, if I use displacement, no matter what you're doing here, you're still going to break it up into its components. Okay, so if you want the x component, you look at the cosine. But if you want the y component, you look at the sine. And these will be numerical values. Okay? They're going to be numbers, and those numbers will be smaller than 30. How do I know those numbers are going to be smaller than 30? Well, this is really a right triangle. This is really Vx. This is really Vy. And what's the largest leg of a right triangle always called? Hypotenuse. And this 30, this right here, this is the hypotenuse. So if you're given that 30, V's, Vy, and Vx, they've got to be something different. Okay, they've got to be something different. Masha, can you turn the air conditioner on to show that window, please? It's not getting cool enough in here. People are getting warm. So, again, remember x is cosine, y is sine. X is cosine, y is sine. What do we have for time in this period, guys? 38? Okay, we got about 4 minutes. I'm going to stop here and I'm going to get set up for the lab.